Welcome to Write Rules Part 1 video. This is about translating words to algebraic expressions. Okay. We're going to explore the connection between input-output tables or function tables that you have learned previously, patterns, and functions. Okay. First, we're going to discuss the word function. It is a relation that assigns exactly one value for y to each value in the domain x. Before, in the previous lesson, we did not talk about y as the range and x as domain. But as we go on with this lesson in writing rules, I'm going to talk more about y being the range and x being the domain. For example, we have discussed this and I hope that you can follow. Y being the rule, y given the function, so I'm going to use rule or function interchangeably. Okay, y is equal to negative 4x or negative 4 times x. Given the values of x over here in this table, the first one, the value of x is negative 5. So if we replace x by negative 5, it's going to be negative 4 times negative 5, which is 20. So what I would like you to do if you're watching this video is to stop the video or pause the video and answer the rest of the questions. Okay, let's check your answer. If x is negative 3, your y should be 12. When x is 0, should be 0. If x is 8, then y is negative 32. If x is 20, then y is negative 80. Okay, let's keep going. Now let's start translating words into algebraic expression. Here is an example. Translate the sum of 8 and y into an algebraic expression. Remember that algebraic expression does not have the equal symbol. So just like what we've talked about, algebraic expression is an equivalent of phrase in your language subject. So the word sum will indicate that we are adding. So we're going to add 8 and y. And so to write the algebraic expression, you're given the variable y. So you're going to use y and it should be 8 plus y. Okay. Another one. Translate 4 less than x into an algebraic expression. We have the constant 4 and the variable x, and less than should indicate subtraction. So we're going to write the algebraic expression x minus 4. Now remember, less than is backwards in the math from how you say it in words. So whenever you see the word or the phrase less than, you're actually doing it backwards. We're going to have another example later. Okay. To make it easier, I have listed some words that will give you clues as to what you're going to write in your algebraic expressions. Okay, going back. These are sum, more than, increased, plus, and altogether. For subtraction, decrease, less, difference, minus, how many more. For multiplication, multiply, times, product, times as much, of. For division, you may see words such as divide or by or divided by, quotient, per, the ratio of. Okay. Translate words into algebraic expression. Okay. What if the words are x multiplied by 13? Because we see the word multiplied Okay, so that means it's multiplication. We can write the algebraic expression as 13x. Okay, remember, if you don't see a symbol in the middle or in between, that means it's multiplication. Another example, the quotient of x and 3. Okay, we can write these words into this algebraic expression, x divided by 3, this symbol, or you may also write it in fraction, which is x over 3, or x. You can also read this as x divided by 3. Remember that your dividend is the numerator and your divisor is your denominator. Okay, now I'm using a page in mathgoodies.com to give you more example about writing algebraic expression. But at this point, I'm writing equation. And you know, when there's an equation, it has an equal symbol and the result. Okay, so let's say we would like to write the algebraic equation for twice a number is 28, because we have the word is and it's giving you a result 28. Okay, so that means the result is 28 twice a number. That means 2 times a number. So we're going to look at here which one describes this sentence. Is it x plus 2 equals 28? Is it 28 equals x divided by 2? Is it 2x equals 28, or none of the above? Twice a number does not represent addition. Twice a number is not division. We know twice a number is multiplication, so twice is 2 times, so we see 2 times is 28. The result is 28. So let's choose this, and it's correct. Next sentence. The quotient of 39 and a number is 3. Okay. We know from the words that I have given you that quotient represents or mean division. We have a constant, which is 39, and a number can be represented by a variable. Okay. Is talking about a result, and the result should be 3. Okay, or the same as 3. Okay, quotient. Looking at our choices, I can only see one division sentence. But then we are not sure yet because it could be none of the above. Okay, but it says the quotient of 39 and a number, so 39 divided by a number, and a number can be represented by the variable w, is the same as or equal to 3. Okay, let's choose this one. It's correct again. Okay. Let's move on to the third. 5 less than 3 numbers, 3 times a number is 46. Okay, I'm going ahead with is 46. I know is 46 is the result. So I have all 3 choices that says equal to 46. So I already know that it's equal to 36. Now, 5 less than a number. We discussed less than should be backwards. So that means 3 times a number should be first. 3 times a number. Times represent multiplication. So I have 3 multiply by a number. So a number can be a variable. So 3 times a number. Where is it? Okay. I have 3 times a number being the first only in here, but it says less than 5, so it should be minus 5. So let's choose B. I'm going to choose it. Okay, it's correct. Okay, now I would like you to take a look at number 4 and number 5. Pause the video and then try to solve them and see if you will get the answer. Number 4 and 5 are more challenging than the previous ones. Okay, let's continue. Let's see if your answers are correct. Okay, 3 is 21. divided by the sum of a number and 5. So 3 is the same as, or 3 is equal to, so we want a 3 at the other end. We only have that here, and it could be that there's no correct answer here. So we're looking at this. Let's check if this is going to satisfy the sentence above. It says 3 is 21 divided by the sum of a number and a 5. So 21 should be divided by sum represents addition, sum of number 5 of a number and 5. So it should be a number and 5. So number plus 5. Do I see a number plus 5? We have 21 divided by a number, and then you add the quotient to a 5. So that means this is not the correct one. So I'm going to choose none of the above. Okay. So your answer should have been none of the above. Okay. Number 5, Eric had $197 in his savings account before he was paid his weekly salary. His current savings balance is $429. How much money does Eric earn each week? We know that the balance is $429, so the answer should be equals $429. I only have two choices here, B and or C. But it could be none of the above. So let's check the sentence before that. Eric had 197 in his savings account before he was paid his weekly salary. So that should be $197 and a number. And we could use plus as that, plus n, and it should equal to 429. Okay, so your answer should have been letter B, 197 plus n equals 429. Again, from mathgoodies.com, we could take a look at some more examples of algebraic equations, from a sentence to algebraic equation. I hope that you see the difference. Now, when you were translating words into algebraic expression, I was giving you phrases. Okay, at this point, we are using sentences and you are giving algebraic equation. Okay, we have more examples. A number increased by 9 is 15. Okay, increase implies addition. And remember, a variable can be represented by any letter in the alphabet. So you could use Y, A, B, C, D, whatever letter you want. So a number, which is y in this case, increased by 9 plus 9 is 15. So you have equals 15. Twice a number. We did this in the previous example. Okay, that's 2 times a number. So 2n equals 18. 4 less than a number is 28. Okay, we already discussed when you see less than, it should be backwards. So your number goes first, x minus 4 equals 20. A number divided by 6 is 8. So k is your number, which is represented by a variable k, divided by 6 equals 8. I hope everything is clear. Now, to check your understanding, go to your board patterns and shapes in our website, in your web page, and open post number 9. Answer all the questions there, and we will check them in class.